Hello there, once again, thank you so very much for joining us here. Today I want to share with you some mathematics, and the math I want to share with you is what we are going to call the remainder theorem. And in the remainder theorem, I will need to remind you of how we used to divide. We used to divide at the primary level. You would have maybe something like what? Something like 3 and divide it by 10. And the first thing you would know that it goes there 3 times. So 3 divided by 10, it goes there 3 times, which 3 gives us a 9. Then you multiply 3 by 3, you would get a 9. Then you would subtract. And the balance would be 1. If the balance is a 1, then that means 10 comes from what? From 3 times 3 plus its remainder, which is 1. So 1 would become what we call the remainder, whereas the 3 times 3 is what we call the quotient, as we shall see. So even here at advanced level, we can divide functions. And when we divide functions, we can divide them in this sense. For example, I can have a number in the sense of an illustration like this one. We can have x minus 2. I'm dividing it with x cubed minus 3x squared plus 6x plus 5. And this is the number we need to divide with what we call the remainder theorem. Sometimes people call it long division. So if I divide, I will divide x cubed with x. So I divide the highest degree here with the highest degree there. So x cubed divided by x, I get x squared. Like I did multiply the 3 by 3 to get 9, also multiply the x squared by the whole of this divisor. In that sense, I'll have x cubed minus 2x squared. When I do so, I subtract. When I subtract, I will eliminate the highest degree, which is x cubed. I'll be left with negative 3x squared minus a minus 2x, giving us a minus x squared. 6x has nothing to subtract, plus 6x. 5 has no constant, plus 5. Then we differentiate again. We divide again. Divide the highest degree here, because now this is the new item we are dividing. So we are dividing x squared with the whole of this. I divide it with x. So I'll get a minus x. Then I'll get a minus x squared plus 2x. When I subtract, I'll realize x squared will die off, which is a negative x squared, becoming 0. Then we shall have 6x minus 2x giving us 4x plus 5. With this, I can now have the highest degree of x is 4x, divide it with x. Those of you who don't remember how to divide, you can say 4x divided by x. You see that you get 4. The x will die off, leaving us with a 1. So plus a 4. Now this 4 multiplies back the whole of the divisor. Actually here, the 3 alone was the divisor. So even here we are going to see that x minus 2 is the divisor. This is the polynomial we are dividing. What we are getting here is the quotient. What remains will be the balance. So 4 times the divisor, we shall get 4x minus 8. When you subtract, we shall have a 0. Negative 8 plus 5, the answer is 13. You divide until you either have an x here, or you have a value of x which is smaller than the highest degree of x in the divisor. That's when you stop dividing. And if there is no 0 here, it means it is not divisible fully by this factor. It means it leaves a remainder once this factor is the one dividing this polynomial. So therefore, the solution will have x minus 2 as the divisor. We shall have x squared minus x plus 4 as the quotient. we shall have 13 as what we call the remainder. That's why it's called the remainder theorem. Then this is what we call the polynomial. The polynomial which we have been dividing with. So this is the polynomial, and that polynomial, if I'm to go back and extract out what the polynomial is, the polynomial in most cases we call it P of x. So if I'm to summarize P of x, it will be P of x. If you go back to what I did in the beginning, I showed you that we had the remainder 1. 1 corresponds to 13. We had a quotient. Which quotient was? The quotient is what we got. So the quotient is this x squared minus 6x This quotient was, here the quotient was 3. So this is the quotient. This one is the divisor. This one is the remainder. Now, the 10 is our polynomial. So if I may extract it out and I write it in general, then I'll have the following. The polynomial is always given by the quotient in terms of x times the divisor in terms of x plus the remainder, which could be also in terms of x. So sometimes the remainder may be in terms of x, or sometimes the remainder may be a constant like this one. If we do more examples, we shall realize that at one point, some of the examples we do go for will have remainders which will not be constants. For example, if this was a divisor which has x squared, and the remainder here is 13x, you will be having a remainder of linear x, yet the divisor is of a quadratic format of higher degree, which is degree 2. So in that sense, you will be in position to see that the remainder can be also a function in terms of x. So this becomes the general expression. That is the general formula or general expression. Allow me to leave you with one to try out. Try for me dividing this. Divide 4x cubed minus 6x plus 5 by 2x minus 1. I would love to see your answers in the comment section. Make sure that you put your answers there, and then we can get to know whether people are really following rightly these illustrations that we are trying to demonstrate. With that, I would like to thank you once again for joining our channel always. Thank you for watching, for liking, sharing, and subscribing. For those of us who have not yet hit the subscription button, please do, so that you can promote and support this channel always, so that we can produce more content year in, year out. With that, see you next time.